then following conditions are equivalent. Following are equivalent. Number one, S is rectangular band. Second is every element of S is idempotent. And ABC is equal to AC for every ABC belongs to S. Or there exists left zero semigroup L and the right zero semigroup. And the right semigroup are such that S is isomorphic to L cross R. And fourth condition is that S is isomorphic to a semigroup of the form A cross B. Where A and B are non-empty sets. And where multiplication is given by A1 comma B1 into A2 comma B2 is equal to A1 comma B2. So this is theorem 1.3 and page number 7. So how to prove such type of theorems? The following are equivalent. It means what? First implies implies second, second implies implies third, third implies implies fourth. All conditions are equivalent to each other. Is it clear? If this happens, this also happens, and this also happens, and this also happens. So how to prove such type of theorems? What is the approach? Approach is that we prove first implies second, and then we prove second implies third, and then we prove third implies fourth, and finally we prove fourth implies 1. In this way, this result will be proved. Correct? Remember, my students, what is the tactic to solve a mathematical problem? First thing is to understand the problem. If you don't understand the problem, how can you approach? Every approach will be wrong if you don't understand the problem. The first thing is that to understand the problem. Number 2, right approach. Because right approach means what? Right approach means does not mean only that it is not a wrong approach. Right approach means it is precise. Because, for example, if we have to go to some place, for example, if you go to, I'm in Aligarh and I have to go, for example, in center point. So what is the way to go center point? There are many ways to go center point. If we go opposite to that, then it is wrong. But if we are approaching to center point in a different ways, we have to select that way which is the shortest way. Just like the Google Maps. isn't it? So right approach means the approach which is the best approach, the shortest approach, simplest approach, precise, no irrelevant things should be included in that. So that approach is a right approach. And third thing is that to complete whole problem from A to Z, total, all steps, algorithm, and step by step, you do whole the problem. Approach means initiation, and to solve whole problem you have to write all steps. So in this way you will be able to solve whole mathematical problem. But first thing is that most of the time what happens when we are doing exams and we see in the paper the problem, whenever we appear in any type of interview, when anybody asks question to us, so sometimes what happens, we are unable to understand the problem. So first thing is that try to understand what is the problem, what the problem is saying. Now here is what, let's see, first we prove that first implies second, correct? That is, S is rectangular band, and we have to prove that every element of S is idempotent and ABC is equal to AC for every ABC belongs to S. So see what we have. We have, let S is a rectangular band. That is, A is equal to what? ABA for every AB belongs to S. So try to understand what it is. It means that every element can be written as same element into any other element into again same element, which is at the first place or which is at the left hand side. For example, it means that you can write just like this: A is equal to ACA, A equal to ADA, like this, A equal to AEA. Similarly, also you can write C is equal to CAC, D is equal to D, BD, and D. It means this. A semigroup S satisfies this identity. A, B can be any elements of S. So this you have. Now what you have to prove? You have to prove that every element is idempotent means what? A square equal to A for every A belongs to S. Claim is what? A square equal to A for every A belongs to S, and ABC is equal to AC for every ABC belongs to S. I already told you that rectangular band is a band, but this time you have to prove it. This is the definition of what? Band. That if every element is idempotent, it means what? It is band semigroup. It is band semigroup. So rectangular band is a band semigroup. This is a fact. But this time you have to prove. Now how to prove? See the proof. See, you can also write since S is a rectangular band, therefore A is equal to what? A into A into A. You can write, isn't it? You can take A in the place of B. So it will be what? A cube. Correct? Now if A is equal to A cube, it implies what? It implies what? A square is equal to A to the power 4. Correct? You just mention it like this, say it is 1. Now also A can be written as A into A square into A. Because A is a rectangular band, you can take in the place of B A square, you can also take in the place of B. So A will be A into A square, this is what? This is A to the power 4. So A equal to, that is A is equal to A to the power 4. This is second. So first and second implies what? A square equal to A to the power 4, A is equal to A to the power 4. So first and second implies that A is equal to A square. So you have to prove. Correct? Now you have to prove that ABC is equal to AC. ABC is equal to AC means what? It means that first element into second element into third element is equal to first element into third element. It will absorb middle element. It means that. Anyway, now see how to prove. So you can approach this. I'm dropping. Copy it down. Now you can go from the left hand side, you can go from right hand side, it's your choice. For example, if you're going from right hand side, that is AC. Correct? So you can write A as ABA and you can write CBC. Since S is what? Rectangular band. You can give the logic. A can be written as ABA and C can be written as CBC. Now you can just write A, B, A, C, B, C, C. You can write like this. Yeah, since this is a semigroup and associativity holds, so you can just bracket like this. Now AC is some element, correct? So B into some element into B will be what? Again B. Of course, since again logic is what? Since S is rectangular band. So in this way it is proved AC is equal to ABC. So you have proved first implies second. Is it correct? Now we will prove second implies third, and third implies fourth, and fourth implies what?